Gonna-
Hey everyone, welcome to the VictoriaMetrics features and community call. First off, we just want to say that hey, we were on a different stream a few minutes ago. So here we are now, and we want to welcome you to this. This is an event where we're hoping to share what is new and interesting with VictoriaMetrics and our products that our users may not have learned yet. So we're going to go through that today. We'll have a demo where Roman will present to us. And then we've got myself and Matthias who are here. Again, apologize for starting late. We had some great conversation on the other stream. So that was all to ourselves. One day we're going to nail this and it's going to be, we'll pop the champagne. So again, today we're super excited to just be able to focus on what are the new features, what's interesting in the product, just to offer a different way for people to consume and learn about VictoriaMetrics. So I'd love to introduce Roman and Matthias. You guys want a quick intro to yourselves before we hop right into it?
Sure. Hi, my name is Roman. I'm engineer manager at VictoriaMetrics in the open source team. I'm mostly responsible and focused for what is happening to metrics, and less related to what's happening to logs. That's me, Matthias.
I'm Matthias Palmersheim. I'm a solutions engineer at VictoriaMetrics and a happy user. So I help people both our enterprise customers and the community get the most out of VictoriaMetrics and Victoria logs.
Awesome. Cool. Well, let's kick it off and dive right into the good stuff. Roman, we'll turn it over to you again. One thing, housekeeping. Sorry, anyone. If you do have any questions, we want to make this as interactive as possible. So please feel free to post them into the chat window. We will try to address them here. But this is really about sharing both directions, bi-directional sharing. So we want to make this as interactive as possible. So take it away, Roman. Thanks.
Yeah, thanks, Mark. So we will try to keep it as casual as possible without slides, without like prepared talks. It's all live. You can ask questions also live. We'll try to answer or discuss them in live. My today's presentation will be focused on the features that I'm used to use on my own during working hours to help other users, to help VictoriaMetrics customers to understand the metrics better. And I will just show what I'm usually doing or what may be fancy features that you didn't know yet exist. What I will try to show you is that I will install the Kubernetes Kate stack Helm chart on my local machine. We will see what it deploys, what metrics we collect, what can we make sense of those metrics, and can we optimize those metrics. It will be touching stuff like Cardinality Explorer and metrics names usage. And we'll see what we can get from this information. So for this, I will have to share my screen. Let me do this. I hope you see it now. Do you? Okay. So I hope that Matthias will ask some questions if something is unclear from my demo, so feel free to interrupt me if anything. What I have here is I have a terminal and some configuration files for the Kate stack. This values file is generated from the guide that we have in our docs at victoriametrics.com for Kate stack, and it has nothing special. It's just default values. And I deploy this to my, sorry. Whoa. And I deploy this to my local Minikube. And here, what we have here. So we have VM agent, which discovers targets and collects metrics, and it sends this to VM single. VM single works as a metrics data source. It accepts data, stores it, and responds to the queries. We also have VM alert together with VM alert manager for alerting rules. We also have Grafana for dashboarding. We also have Node Exporter and VictoriaMetrics operator. Node Exporter just exports some metrics, and operator handles all this stuff. What else I have? I forwarded port from VictoriaMetrics single And let's see what we can we make sense of what VictoriaMetrics single has. So usually when we're talking about what metrics we store, how important they are, what generates the loads, I recommend everyone to go to the Cardinality Explorer. That's the feature that I think is very important to every user, and it gets a lot of insights in what you actually store. So when I go to the Cardinality Explorer, I see the information for the specific date. It's only for this date. I run this demo for 2 days, and it's local laptop, so it's was not always collecting the data. But anyway, it has some metrics inside. And just checking on this Cardinality Explorer, I can see my top most important metrics.
Are you trying to share your web browser right now, Roman?
Yes,
it looks like you are only sharing your terminal still.
Okay, one second.
And while that came in, we did have a question that came up while you're switching that over. GTP was asking, when you're going to install all of that, could you please mention if you collect events? I'm not sure if you need clarification on that, or does that question?
By events, so by default, the Kate stack will deploy cube state metrics. And that can be turned off. You can turn most of those types of things off inside of the Kate stack. By default, I don't think the Kate stack deploys Victoria logs and vector for storing like log events and those sorts of things. That should be on the roadmap if it isn't on already.
Yeah, it is on the roadmap. So this VictoriaMetrics Kate stack, it doesn't have the Victoria logs in it. For Victoria logs, there will be different charts, and I think there will be also a big chart which unites metrics and logs together. But it is this call is not about logs; it's mostly about metrics. So we don't have Victoria logs here.
And the reason why that doesn't exist yet is a dependency, right? So the Kate stack is a big Helm chart made up of a bunch of other Helm charts, like a nesting doll. And so right now we just so there's been a single chart out for a while, but the cluster chart just got released. So then that can get put into the operator. And then once it's in the operator, we could expose it through the Kate stack.
Yeah.
That's the thing that I think trips most people up when they use the Kate stack, is just that it's really like a meta chart where it's just deploying a bunch of other Helm charts in the VictoriaMetrics operator underneath.
Yeah. That's true. So yeah, in short, we don't collect events, we only collect metrics. And yeah, so sorry for not showing it for earlier. I thought I demonstrated my whole screen. Anyway, here we are on the Cardinality page.
Sorry, Roman, could you zoom in just a little bit more? Sorry, we just got some feedback. Sure. There we go. It was a little bit fuzzy. Thank you.
Like this is better?
That should be on my screen. It looks great. If any of the users have any issues, just let us know. Thanks.
Okay. So yeah, what we see here, by default, we're looking on the current date. It will choose the current date, and it will show you 10 entries only. This is actually done a bit similarly to how co-profiling works. So when you profile your program, and you first what you do with the profile, you type command top, and it gives you top 10 functions or lines of code which are consuming the most of time. Here we have 10 top most expensive metric names. And we can easily say that these metric names, they like usually use the most of your resources on query time and on ingestion. In fact, it also calculates the share. Like, for example, API server request duration seconds bucket is responsible for 11% of the metrics that I collect here. And yeah, you can see other metrics. You can also play with this stuff. You can show more entries here to understand. You can also click on the metric to get more details what it consists of. I mean, this is just a metric name, but to form a time series, it has this bunch of labels. All these labels, like in some way, contribute to the cardinality, which makes this metric expensive. And Cardinality Explorer will try to explain it to you, like what we're looking at with all these helps, all the stuff. It will also try even to compare the current state with the 1 day ago state, because I will remind that we're looking at specific day here. It's not all the data that you store. We just scan and index for 1 day, because otherwise scan and index for like 360 days will be too expensive to do. And since we're mostly concerned about optimizing what is happening now, because we can't change things in the past, we looking at the specific day. So what usually is important when you look at Cardinality Explorer, we see that this metric, for example, is the most consuming. It would be very cool to optimize it, but we don't know if this metric is actually useful. We don't know if this metric is used by anyone, by recording rule, by alerting rule, by dashboard, or maybe someone just occasionally query it. So we have this cool feature, which is available 2 versions already from 1.16, if I'm not mistaken. And this thing is called metric names tracker. And you can go to the documentation to read more about it and how to enable it. So we go to the track ingested, the section called track ingested metric usage. And what it actually does in VictoriaMetrics, it creates an in-memory registry of all metrics that were ingested like right now, and it updates this registry every time when someone queries this metric. It holds only metric names. It doesn't hold time series. And the reason for that is that metric names are usually very limited in cardinality. Let's try to enable this stuff, because if you see here, it says NA. It means that it's not enabled. And in order to enable it, we need to update our configuration a bit. So to do this, I will need to update my values in the Helm chart. Let's find my VM single. And here I have it commented here. So let's try to apply this configuration. Basically, I'm passing the extra arc to VM single, and I'm saying that I want to enable this feature flag. And let's apply it, and we'll wait for this to happen.
While we're waiting for that, Roman, real quick, obviously having a unused metric and having it one of the largest that you have, what are the advantages? Like, why do I want to get rid of those? Like, if somebody creates a metric and it's loading up, is it just for storage space or performance? How does that make my life better by getting rid of the unused ones?
Well, it impacts everything. Like, if you would talk what is the most expensive thing is in the time series databases, it's a cardinality, mostly because all the databases, VictoriaMetrics and Prometheus-like things, they have an inverted index which helps to match labels to a specific time series. And the more these combinations you have, like the more unique time series you have, the bigger will be this index. And if this index doesn't fit the memory, then you will have to like offload it to disk. And on the query time, you will have to touch the disk more frequently and pollute other caches, etc. So it impacts everything. The query time will be slower. You will consume, you will spend more resources, CPU and memory, on storing high cardinality data. You will see high disk I/O, and you will see a smaller compression ratio just because you have like huge variety of time series. So if you want to optimize something, the best thing you can do is to reduce churn rate, then reduce the cardinality. Okay, so I enable this stuff. Let's see if it's working. Okay, so it is working, and if you see these numbers, they actually now populated. It basically says that in my registry, I have 2,000 unique metric names. And this is why I'm saying that metric names are limited in cardinality. I have 60,000 of time series, but only 2,000 metric names. And these are, since I'm collecting these metrics in real time, these are all ingested metrics that we have right now. So yeah, the relation, for example, is the following. The API server request duration seconds bucket is one metric name, but it has 6,700 time series behind it. So we store only metric names here, and we track how many times something was queried. So for example, we see that the most expensive metric that we have here is never queried. It has 0 request count, and last time it was queried never. On the other hand, there is a API server request SLI duration second bucket, which was queried many times. So this number is actually shows how many times the time series, like every time you query this stuff and it returns you like 4,000 time series, that's how many times the counter will be incremented. So this is not actually amount of execution for this metric, it's amount series matched during the lookups.
And I'm guessing that's coming from a recording rule. You didn't just sit on a dashboard and refresh it 23 million times, right?
Yes, I don't have any dashboard right now opened to refresh. So it's usually all this queried, something queried, it's only alerting rules or recording rules. And it also says when this was queried. And it's very important that we have this feature, this attribute, because you can tell how frequently this one is refreshed. For example, if someone queried API server request duration 1 month ago, you will see that it was queried 1 month ago. And this will give you a hint. Someone occasionally maybe queried it, but if it was queried 4 hours ago and you check it tomorrow when it's again 12 hours ago, it means someone is using it, right? So you can drop it.
Luckily, it doesn't have a label that says who created that metric, or somebody would be like, hey, Matthias, stop creating these giant, expensive, unused metrics.
Yeah. So what else we can do with this stuff? For example, we can filter out by arbitrary time series selector. So we have node exporter, right? So let's see if we have something for node exporter. Here we see all the metric names that are having job node exporter, and we see that some of them are actually also taking part in the alerting rules, but we don't know, maybe these metric names are used in the dashboards too. Sorry, I got interrupted with the Nairo stuff. How does it work? Is the data stored in memory, and will it disappear if I restart the pod? Data is indeed stored in memory, but this in-memory state is persisted on the disk when you gracefully shut down the storage, and will be reread again when you start the storage. And you also can reset this cache by manually deleting it from the disk, or by issuing the API call to reset the cache. You can find more information about this here somewhere. And it also explains which API calls actually increment this metrics, what it tracks, what to do with cache, the limit of the cache size. Yeah, you can find it in the track ingested metric usage. Yeah, and if you want just to play with it, it's also available on our playground. We have this enabled here on the public playground. This public playground, as you see, it has almost 300,000 series and only 7,000 metric names in the tracker. You can play with all this stuff just on playvictoriametrics.com if you're curious. And it's open source. You can install it right now from the latest VictoriaMetrics version and play on your own. Okay, so what I wanted to show, node exporter. So we see that something is queried by recording rule or alerting rules. Let's see if there are any dashboards that actually using this. For that, I need to go to Grafana. Okay, I don't have it. I probably need to port forward it. Let's see the Grafana port name, pod name, sorry, and let's proxy to my local machine. Grafana. It's usually 3000 port. Let's see if it's working. It's working, but I need creds. So I need to ask for creds from the secret. 1 second, I have a command for that. How to extract secret for Grafana, and it's like this. So should I explain how this works? Matthias, what do you think?
Fetching that secret? Yeah, I think that'd be useful. So my understanding is that the Kate stack changes the default admin user in the Grafana Helm chart. and then it stores it as a Kubernetes secret, because if you don't do anything, Grafana will set the username and password for Grafana to admin, which is not good.
Yeah.
And I believe in the Grafana Helm chart, you can turn off the admin account. I know in regular Grafana, you can turn off the admin account entirely if you're using SSO for everything.
Yeah, probably. I'm don't know all these details about security management. For sure, Grafana has elaborate documents how to do this, and it's also Grafana deployed here as a part of their chart. And yeah, it generates a random password and puts it into the secret when you install the KStack chart. And in order to get this password, you can just decode it from the secrets if you have access to this Kubernetes cluster and have permissions to read secrets. So here, what we did is we get access to our Grafana, and we see that we have the node exporter dashboard, or we're supposed to have it here. Oh, node exporter full. So as I said, this is on my local machine. So when I sleep, it doesn't collect metrics because my laptop is shut down. So we don't have we have these gaps. But my laptop was up for last 1 hour at least, and we have some metrics collected out of the box. When you install KStack, it will install node exporter and a bunch of other exporters, and it starts collect this useful metrics for you. It will deploy alerting rules for you, dashboards for you. So you have this out of the box. Let's try to open these panels just to show, to contribute into metric usage. So in short, if anyone kind of uses this node exporter dashboard, you will know about this in the metric name usage. So we can return back and see if something got updated. So something was updated. If we wait for some time, we should supposed to see a difference that something was updated like a minute ago or something like that. But for that, we will have to wait. And you also can do this manually. Like if I go and, for example, we have this. No, let's check nodes NFS request total. Let's just execute it. And in order to not do it, I will do this. Let's do this. And bam, it's now was requested a few seconds ago. So it's completely interactive. If someone did a like ad hoc query or executed dashboard, you will see it immediately. And as time will pass, you will see exactly when this was queried. Oh yeah, for example, yeah, we waited and we see that node file system device error was queried a minute ago, which means this is not a part of alerting rule, because alerting rules are executed like, I don't know, every 30 seconds. And this is, you see, it was queried from the dashboard.
Do you know if the KStack makes VM alert visible to you by default? Or is that something, would you have to set up the proxy URL for VM alert in order to see that inside of the UI?
It's installed as by default. Yeah, so in VM UI, you have this link. It basically makes a proxy forwarding to VM Alert UI. And then you can check all the rules deployed for you here and their execution. And probably we have a node exporter somewhere here. Node exporter. Yeah, and this is the rule for node exporters that are executing every 20 seconds.
And so if you wanted to turn any of these off, it's just a bunch of toggles in the Helm chart, right? Like you just switch true to false for a value in the Helm chart. So the KStack has a lot of our opinions baked in, and if you don't like our opinion, we make it pretty easy to disagree and turn it off.
Yeah, sure. You can tailor it for yourself, but usually people won't like to press one button, Helm install, and get a bunch of metrics that they will never look at. Yeah, but you can tailor it for yourself, of course. But the point here is just to get insight on what is happening here. Yeah, so you see this node NFS was requested 2 minutes ago, which is definitely an ad hoc queries, while others get updated pretty frequently. Okay, so what else we can do with this? Let's get back to our default thing. So we see that API server request duration seconds bucket is not requested. Let's see to which job it belongs. Sum by job, just to understand what is this. This is API server, so it's Kate's API server. Let's see, maybe there is a dashboards for Kubernetes which queries these metrics. So yeah, we have the system API server dashboard, and it's even working. It's even showing something. Look, let's okay, these are all panels that it has, nothing else. Let's see if this dashboard actually contributes to the metric name usage. Oh yeah, it actually contributes. So this dashboard is using this. Oh no, I made a mistake. It is not a dashboard, it's I queried it.
So you queried it, and so because you only queried that metric once, it shows exactly that number of time series because that's how many times that time series was touched.
Yeah. So in my demo, I wanted like to show you that this metrics is useless because this dashboard is not using it but by mistake I queried it, and this registry remembered it.
So but we're proving that it's useless because we can track exactly how many times we queried it. So I think we're still okay.
Yeah, and for anyone
your demo
who's
is
watching,
still safe.
Yeah, anyone who's watching is like, metrics sometimes can be tough. This is proof that this is why you want to learn more. Even an expert can sometimes get caught up.
And it's also proof too that I think that's the official dashboard for the Kube API server. And that dashboard, like we scrolled through the entire dashboard and we didn't touch our highest cardinality metric.
Yeah, let's try to refresh it again just to see if I'm not mistaken that this metric is not used. Yeah, so still, it's 2 minutes ago. It was me who queried it, and no one else has queried it. So let's try to understand what this metric is, because again, it's contribute for 11% of all the metrics that we store in this demo. And this is, as you can tell, it's a histogram because it has less equal label. And mostly it is, it has so high cardinality because of combinations of less equal and combination of things like resource and verb. So resource is actually to which resource it measures. Sorry, what was the question? Can you show it again?
Oh, it was a comment that if we did want to confirm the that metric wasn't used in that dashboard, we can go to the JSON and control F for that metric name.
Yeah, sure. I know about existence of Mimir tool, which can analyze your alerting rules and recording rules and Grafana, but it only can do this. If you query this metric, for example, if you queried this metric 20 days ago during the incident review, Mimir tool will not show you this.
Correct.
But, yeah.
But what Yuri was trying to say is that if we wanted to confirm that that metric was in that dashboard, if you go into the settings of that dashboard, you could actually like find certain metric names inside of the JSON. You're just like control Fing through a JSON document.
Well, you can make a query which doesn't query metric name. It can query just jobs, or it uses regular expression with I don't know, yeah, whatever. It's not a guarantee that this metric is not used. So still, okay. So it has this resource stuff which contributes to cardinality. It also has a verb stuff which lists the exact action, the API call that it does, and measures it. What can we actually calculate from this metric? Well, we can probably calculate the histogram, the latency of these requests, right? What else we can do from that? Let's try to make a dashboard actually to make this metric useful. Okay, Grafana interface is always changing. Let's make a new dashboard, and yeah, I will. It goes by default with VictoriaMetrics data source, and let's try to plot something. We have a time series stuff, and I would like to display probably the
P50 and P99.
Yeah, anyone knows how to write it without mistake from the first?
It's like histogram quartile. I'm gonna cheat and look up how I do the histogram in another dashboard.
And while you're looking that up, we did have another question came in, is could you show how to query a metric without a metric name? So I don't know if that fits in now or if you want to address that later, but that seems like an interesting.
Sure. Like, okay, let's try to query something not so high. Oh, okay. It's very, very simple. You can do this. For example, node exporter like this. Yeah, node exporter like this. Here I'm querying metric without metric name, and it will count. It will query actually how many. It will query 2000 time series with this. You can do count by name. Let's switch to table because it will be verbose. Why? Oh, it was not executed. Yeah, so here I queried all these metrics without actually pointing their name.
And double underscore name is another way to access the name of the metric, right? So the name of the metric is just a special label, right?
Yeah. And also, for example, here it queries all the stuff that belongs to this. I can also do the regular matching to the metric name. For example, I want to get all Go metrics. I'll do this.
And if you're doing a direct match, is it the same performance? So obviously a regex is going to be slower than a direct match. But is there any performance difference to doing like double underscore name equals to just referencing the metric normally?
Well, of course it has the performance because it will, if you don't do the regular expression, you match only one metric name, right? And here I'm matching 157. So different metric names. So of course, it's by definition will consume more resources.
But if I just did a direct match, would it matter if I did it the double underscore name or the metric name outside of the label selector?
You mean, is there a difference between this and this?
Correct. Or not the with or without the regular expression. If you did double underscore name equals go underscore C go. Okay.
No difference. Okay.
Do you guys know a use case where you would want to run that? Is that for a group of metrics where I know I'm looking for my Go CPU, but I know there's a ton of metrics names. I don't know them all, so I can just say for that suffix or prefix. What? Just wondering about the use case for this.
Oh, of course, it's like a part of exploration. For example, I want to learn something about like how many memory allocations happen in the program. I know that there is a metric which measures this amount of allocation, but I don't know its name. So what I will do, like something, I will go mem allocs or something memory allocs. And you see, I'm struggling here. I'm trying to find this. I know it exists, but I don't know the exact name. So what you can actually do, you can go to explore Prometheus metrics, and then you can do this kind of stuff. Like, for example, what have, for example, we have VM single, we do this, and now we can find all Go mem, and here somewhere a log bytes, it's a gauge. We need a log bytes total. Yeah, so I will do this. And this is the wrong instance. Can I do this? Which one is right? I don't know why it doesn't show me anything.
But it's mostly just for like exploration or just like a quick and dirty search through metrics. You usually wouldn't want to use this in production because regular expressions are, one, hard to get right, and two, slower than directly matching.
Mm-hmm. Yeah, anyway, let's go back to what I wanted to show with this stuff. Let's try to execute this thing. Does it work? Oh yeah, it's actually showing something. Let's make it smaller. So it shows the graph, which doesn't make, I mean, it's not very useful because there are some metric some labels here which are too big and some series which are too small, and that's why the scale of this doesn't make sense. For example, watch is like a long polling request, which always takes the max moment of time, right? Because it always like waiting for events. Let's try to disable it and see if it makes better. No, there is also connect, which takes a lot of time. Let's try to disable it. Oh, okay. Now it makes sense. And we actually see some metrics changing, and we can tell, for example, that put is something that I would like to monitor. Let's try to filter by this verb. Just to filter out everything else. Okay, and to make it even more sense, we will add the unit seconds, because we measure in duration in seconds, and we measure in rate of this counter. So this is like on 99% cases how much time it takes to execute put. This is actually, this calculation doesn't make sense because we also need to filter by resource, and now we're summarizing by those resources. So we just looking on average across all resources, which makes less sense. But anyway, here we get something useful, right? This is the
and if we wanted to only match on the API calls that don't have a long poll, we could use a regular expression to exclude those, right? So where you have verb equals put, we could just do verb is not equal to connect and watch, right?
Well, yeah, we can do this like put and get. For example, can we do this? Yep. Poop.
And you can do a negative match as well.
Yeah, yeah, you can exclude everything, and this will be a negative match. But anyway, my point was trying to make sense of the API server request duration seconds bucket, because histograms are usually like they were designed to measure the SLO and SLI and to measure the specific quantiles. So that's why they have these static buckets defined. Like this bucket is, by the way, let's try to Google this metric. We'll see what it will tell us. I already Googled it before. And if you will try to Google, you will see a lot of references to GitHub issues that this metric creates enormous amounts of data. And this is like since the Kubernetes monitoring is happening to everyone is now running the Kubernetes, they need to monitor it, and they collect this metric. And this metrics is not used in the dashboards and in alerting rules, but they still collect it and they still store it. They could make sense of it, but anyway, my point is that everyone has it, and maybe it is not very useful to you. So we'll think how we can optimize it. Yeah. So this issue about API server latency metric creates enormous amount of time series. There is a resolution of this issue, if I'm not mistaken. I was seeing a pull request which was improving the situation. And yeah, it improved the situation by reducing the amount of buckets, and it reduced it twice. Yeah, we can check what actually happened. So
that's been a problem since 2021 is the post date of that. So this has been a lagging issue then, it seems, right? Or people have been just dealing with that.
I've seen that metric, I think, in everyone's Cardinality Explorer I've ever looked at, including ours. Like if you're using Kubernetes, that's probably going to be your highest Cardinality metric.
And unused.
Yeah. And you see what they did, they just reduced the amount of buckets in this metrics. Like what this was the fix. We just reduced its cardinality twice because we reduced the amount of buckets in this histogram.
And a bucket is just defining like a boundary for how fast something has to happen to fall in that bucket, right?
Yeah.
So it's the number of requests that happened in less than a tenth of a second, 1 second. So they cut down the number of buckets in half.
Yeah, but it also means that even if you measured one event with this histogram, it will expose at least the amount of buckets of time series. So this is always a multiplicator. The amount of buckets is always something that get multiplied by combination of all other labels in your metric name. If you have just one metric and 10 labels, the cardinality will be 10. If you add, for example, verb to that metric, and your verb will have like get, put, watch, you multiply 3 by 10, and means you have at least 30 time series. Here we have resources, we have verbs.
You have to multiply by resources and the like 5 or 10 other things that we saw in the Cardinality Explorer.
Yeah, and now you get like 6,000 of time series and you don't use them.
And it's a single node K8s cluster on your bucket. Imagine if you had like 1,000 node K8s cluster.
Mm-hmm. Yeah, okay. So what I wanted to do with this metric is that usually this is the only way to make sense of it. Sometimes people plot heat maps of it, but I didn't, like, I'm not usually seeing that heat map used anywhere. Usually people are concerned about latency of specific type of request, so they put it into the alerting rules. Like if duration to some type of API or some resource does not exceed the threshold, and that's the main purpose of the histograms, not plotting heat maps, but just measuring the exact latency, the worst case of latency. So usually people do this. And if we execute, by the way, this in the here and even without verb, let's calculate how many series we actually need to calculate this stuff. Not much by verb. Oh, yeah. So actually, oh no, we don't need this. Sorry, it was incorrect. Yeah, like this. So in order to calculate this histogram quantile, we actually need 200 series only, not 6,000, 200. And this is, we actually drop in all this extra resources and other stuff. We this request returns us only the verb and the buckets per verb. If we want to know like how long it takes put, for example, we can only have this information, and that will be enough for us to plot this dashboard or have alerting rule. So what I will try to do here is to try to stream aggregate this stuff. And let's see how to do this. I need again to edit my Helm chart values. So stream aggregation is done by VM agent, and it's somewhere here. And I need to put, according to Helm chart specification, I need to put it to the spec. I have somewhere prepared, 1 second, on the different display. I have the rule that I want to apply, and it looks like this. So I will apply it because we need to times for it to kick in, and we will discuss again what it's doing. Yeah, so let's get back to the VM agent. So what the stream aggregation config actually does, it's it prevents. It's not prevents. It instructs VM agent to do some calculations before sending data to the VictoriaMetrics or to any other data source or whatever. Here we instruct in VM agent to look for metric which called like this, and we want to aggregate it over 1 minute time window. And during this aggregation, we want to apply the rate sum type of aggregation. That's basically a rate sum. It's the same as sum rate. We can learn more about this. Oh, 1 second. Here. And there is a rate sum aggregation type, which is the aggregation output of stream aggregation. For those who are not familiar with what is stream aggregation, please check this documentation. And there is also a talk by me about the stream aggregation. But in fact, the killing feature of the stream aggregation is that you can do the calculation before data gets into the database. So if we want to optimize this big histogram, which takes like 11% of our data, we can calculate our rate before and throw out the data we don't need and write only 200 series into the database. And we are not polluting its indexes with this extra information. This is the killing feature, that you protect your database from information that you don't need. And I'm using this rate sum because I'm just replacing the sum rate stuff. I hope that it was applied, and let's see if VM agent got restarted. Looks like it did. And let's see if we have this new metric. So this new metric is supposed to be, oh yeah, we already have it. So stream aggregation by default specifies a new metric name for this. So you can like differentiate the original metric name and the result of the stream aggregation. And it encodes the params of the stream aggregation into the metric name. So it makes it similar to how recording rules naming convention works. It basically, looking on the name of the stream aggregated result, you can tell what this metric does, what it means. Basically, it aggregates API server request duration seconds bucket on 1 minute interval. It aggregates it by less equal, and it aggregates it by verb, and it applies the rate sum modificator. So you can read it and can make sense just from metric definition. And it already supposed to like produce some results. Yeah, it does some calculation. And we can also go in the Cardinality Explorer. Let's try to execute it here. And we see that it produces on limited amount of series. It produces only 200 series.
If we wanted to compare that, we could just do like name is like API request duration buckets dot star, right? So take what streaming aggregation added off.
You mean
and then we could see like the numbers right next to each other. Yeah.
So is that similar in line to the question from Ted? Is can you give the stream aggregation a custom name? Is that?
Yeah, you can give it a custom name, but by default we're trying to do the best to make sense of that name. You can do the custom name, sure.
And you could also omit the aggregated and original metric too, correct? So if you had a use case, like somebody wanted to use VM anomaly with an aggregated metric, you could still keep the raw sample because you have another use for it, but use the aggregated metric as well, correct?
Not sure I got the question. I was thinking of myself.
For this case, it makes sense. We don't want all 6,000 time series being sent. We only want 200 time series sent.
Yeah.
But sometimes you just want to save on compute costs. So you could send the raw samples and the aggregated samples with stream aggregation, right?
Yeah. And you also can discard the raw samples. So far, we send in both raw and aggregated just for demo purposes. And we can try now to compare the results. I hope they will be like at least similar, but there are no guarantees. But here we can replace all this stuff. Some rate, we don't need some rate anymore because we already do this aggregation. We need only, hey, can you Grafana? No, Grafana can't give it this name to me. We'll have to copy it. And yeah, does it work? No. Oh, it works a bit. So it started to get populated recently, and we also need to set the step here because of course, they have different resolution. This metric is collected, original metric collected every 20 seconds, and the stream aggregation produces it on once per time window, so only once per minute. Let's do this. And yeah.
Oh, sorry, I didn't mean to pop that one up, but there was a follow-up question to that: is what part of the config discards the raw samples? Sorry, I got click happy, Roman.
Yeah, we'll get into it. So as you see, we comparing here put and put. Okay, let's do it. Let's do it raw and aggregated. and they're identical. I don't know if it's seen, but they're actually identical. I can do, I don't know how to shift them together, so you can see the difference, but they exactly matching. Like you see row and aggregated, they're the same. And we're doing like the same job, but we only using like 200 series for that. And
you can change the cursor in the dashboard. So if you clear out the unit in the dashboard search, in the dashboard settings, you can show the value for all time series.
You mean switch to short or what?
No, clear the search. Let me grab the name for that parameter really quick. There's a way to show all the values inside of that panel when you hover.
You mean, yeah.
Oh, tooltip. It's tooltip all.
Yeah, you're right. All. So yeah, good call. So yeah, you see they are matching exactly, and that's the result of stream aggregation. And regarding to the questions that Mark asked, like how to discard stuff, let's go to our values. Let's find VM agent again. So here I have this magic thing, keep input true. If I want to discard the original stuff, I will do false and do the upgrades. And it will stop producing this stuff, hopefully. Let's wait. Oh, by the way, how we can validate that it stopped producing this way. In VM UI, we have a cool thing that's called row query, and it shows the the real exported data over last interval. It's hard to show. Anyway, it's trying to show us 7,000 series, but here these data points, as you see, they are not connected with lines, and they are not adjusted to the x-axis. They're actually as row as possible. We are exporting data here, exporting row timestamps, and we're putting it here. So using this row query page, you can see actually how the query, how the row data looks like, not how it's looking like this. Because if you go to the query, it doesn't show it with the dots. It's actually, and Prometheus and VictoriaMetrics doing a lot of work to see you fancy, nice lines instead of unconnected dots. Those lines are also always aligned to the cells. Like if I set step to 1 minute, for example, we see that these data points, they exactly on the same time intervals. They're like, yeah, so anyway, and in row query, you see not real data. I mean, you see how data is actually stored in the database. And we see that we stopped getting it recently when I applied the config. So we are not populating this stuff anymore.
That is something that people get confused about all the time, by the way. I know we're coming up on time. I just wanted to focus on that for a second. Because Prometheus and VictoriaMetrics, when you use the query range API or even the instant query API, you just get, for instant query, it's the most recent sample if it exists in the last step, right? And then for query range, you get one result per step. And so raw query will actually show you the raw samples. So if you do notice something is weird with a query, you have the ability to go back and see what samples actually generated it, right?
Yeah, and it also disrespects like 5 minutes. So it will like see it shows you that this data point actually exists because we're looking back in time for 5 minutes, and row query will not lie to you. It will show you like what exactly is happening here. And yeah, what else I wanted to show? I don't know. Do we have some time, or do you think we should?
Yeah, I think we've got some time. We're running at about 54 minutes right now because, well, we started on time but started in the wrong place. So we can run long, and hopefully anybody who's attending will stick around for another couple of minutes.
Okay. So we did this change. We are not writing this row expensive metric anymore, and it's hard to tell if there is a difference, right? We still have it in the Cardinality Explorer, we still have it stored in the index. And if you go to the VictoriaMetrics single dashboard, you will not see much difference, or actually you will see a bit of difference. Let's make it like this. We see that ingestion dropped by 300 samples per second. So we write in less that it was 2.4 thousand, now it's 2 point something thousand, but the number of active time series still remains the same. Like we have 60K of time series. And the reason why VictoriaMetrics is not like showing you immediate result, because it's a rolling window. And this rolling window is actually, if you look what active time series, it's a VM cache entries. So it's internally, it's some cache which holds the unique metric IDs that were ingested over the last 1 hour interval. This is stored in the cache to help VictoriaMetrics processing the ingestion data and respond faster to queries. And we can actually, we will see difference in 1 hour, but we can try to cheat and reset VictoriaMetrics caches manually. How we can do this? We need to go to the docs, and there's something like reset caches on startup. Yeah, there is a cache removal thing where you can like force VictoriaMetrics to force all the caches. It's not rollup caches, not query caches. It's the internal caches of the storage itself, all the stuff that it stores to make processing of ingestion and queries fast. So what it says, how we can trick this, we need to create a file named like this on the storage database, datapath/cache. In order to do this, I need again to do some trickery, and I need to exec to the pod and of VictoriaMetrics single pod. So I will use this command, and I need VictoriaMetrics single. And here I am on the pod with VictoriaMetrics. You see that there is a binary that is running right now and VictoriaMetrics data. So I'll go to VictoriaMetrics data. It has the cache folder. I go to cache folder, and all this stuff, it's responsible for making VictoriaMetrics fast. And what I need to do now, I need this metric file name. I need just to create it. Touch. Here I created it, and then now I need just delete this pod, because otherwise, if I don't do this and I delete the pod, it will reuse the cache, because caches are persisted. Okay, it's again to make VictoriaMetrics fast. After it gets reloaded, it reads the caches from the disk to make for hot start, right? For hot start. But if we remove all these caches, it will have to rebuild it from the very beginning. So let's delete the pod, cube, catel, delete pod and VM single, and operator supposed to restart it. And it already did. So what we need to report forward it again. Maybe no, maybe we don't even need this, because we have Grafana, which talks directly to that stuff. And now we need to wait a bit until the metrics are collected again from this stuff. Yeah, looks like
that worked.
It already worked.
And if I didn't have access to VM Agent, because like I just have a single node set up, I can use streaming aggregation on VictoriaMetrics single, right?
Yeah, you can do this on VictoriaMetrics single too. Just for demo purposes, I did it on VM Agent, but yes, you can do it on VictoriaMetrics single. I did it on VM Agent because people usually don't run VM single for unknown reasons. People do run VM single. VM single is super performant. Like there are users running VictoriaMetrics single on the with active time series of 50, 80 millions on the single instance, and they're super happy with that. You will just spend less resources with VM single. Compare it to run in VictoriaMetrics cluster to where to keep up with the same load. just because VM single holds everything in one memory, it doesn't need to pack data, transfer it to storage, then get it back from the storage to execute the read queries. Everything happening in one binary, in one process memory. So it's much, much faster and efficient than run in cluster. But of course, it's limited by physical capabilities of the instance. So if you can have like a, usually like if you have less than 10 millions of active time series, VM single works amazing.
Yeah, and the only feature limitation of single is multi-tenancy, right?
Yeah, and multi-tenant, and that's one of the two limitations: multi-tenancy, and that VM single data is not compatible with cluster. So if you started with VM single and you want to migrate to cluster, there is no like a fast path. You need to export, import data to the cluster.
And we have a utility called VMCTL, which can do that, but you can't, it's not like Victoria logs where you can just take a single node and then convert it into a cluster with the same data. You have to copy, or you have to ingest the data through an API.
Exactly. Lesson was learned, and in Victoria logs, the data is compatible. So Victoria log single or Victoria log storage, it's basically the same thing, and there is no difference between them. So you can convert your VL single into VL storage.
Yeah, it's just that one config flag that's moved, right? It's defining what its role is. Well, that's interesting. And I think also too is staying on a single node versus cluster. I think what you were showing and you guys were discussing earlier, looking for unused metrics that are the most expensive ones and going, do I need these, and getting rid of them really ensures that one can stay on a single node for, I mean, as far as, is from a capacity and performance perspective, if you're putting the right metrics in, you're gonna have to work really hard to hit the performance level or cap on a single node.
Yeah,
cool.
And before you wrapping up, I want just to place a hook to the maybe next call. So we find unused metrics and we optimize them, and also VictoriaMetrics can help you to find alerting rules, which makes no sense. For example, VM alert will show you this with the yellow things here. It will show the alerts which are executed on the rules which make no sense. For example, we can have or alert manager stuff. For example, this rule, right? I was looking at this rule or something like that. Anyway, we can find something, or kube scheduler rules. So for example, there is this alerting rule which gets executed all the time, but actually it never ever matches anything. So this alert will never fire. And there are a bunch of alerts that are by default installed and they will never fire, and you will never know about how efficient this rule or no. And VM alert will help you to find those rules.
And this
good housekeeping.
This could cause a failure too, right? Like if somebody made a typo on a metric,
yeah, exactly,
they would never get an alert, because the way VM alert evaluates if something should be firing is if their data. So if you mistype something, it will always show no data.
Yeah. So for example, you have the alerting rule which running on some metric, and that metric was renamed, but you have alerting rule on the different repo, right? And that it executed constantly, but the metric was renamed. How would you know that this alerting rule doesn't work anymore? Like you created that alerting rule 1 year ago, and it worked for you 1 year ago, but now the, I don't know, node exporter version has changed, or Prometheus version has changed, something has changed, but alerting rule is not connected to that event of change. And this is how you can discover alerting rules that never work. And I find it pretty useful. I find it all the time alerts. Basically, when I was making this demo, I found that our Kubernetes operator exposed metric had alerting rule over metric, which was deprecated. And I sent a pull request to fix it. And
that's awesome. Well, and I'm looking forward to these sessions continuing to go on, because like you started off with is, we're developing so many new features and there's new ways to use them, but most of our users download VictoriaMetrics, install it to solve a problem, and you don't have time to look at what's new and what else could you be doing. So hopefully these are These are eye-opening for our users. Sorry, what did you have there, Roman? I just busted right over you. Sorry.
Yeah, sorry, it's hard to stop. I'm just showing the pull request that I made while making this pull request, making this demo. I found this alerting rule, which makes no sense because the metric which it operates by doesn't exist anymore.
Awesome. Well, we should save some magic for the next show because I have a feeling that we could keep on showing stuff and this would be the longest live stream ever because I know that there's so much exciting stuff. We don't have to stop now, but we should because we want to save some for next time. So thank you guys so much for this presentation. The feedback so far in the comments has been that people have found it informative. There's been some really good questions. So I think this is a great initiative and I really appreciate you guys putting this on. So any closing words from either of you?
No, from my side, just I don't know, try remaining active in our community. Try sharing the knowledge that you have about VictoriaMetrics, because from my perspective, our main weak point is that we not talking enough about what we have and how to use it properly. So if other community members can help people who just start learning or have some issues with their stacks, if you can just share the knowledge, share best practices, that would help like everyone. We will reduce the amount of unused metrics over the world.
There you go. That's our goal. Awesome. Well, thank you both so much. Looking forward to the next one. Everyone also, as Roman had said, is feel free to play with us. It is all open source. You can download and install it locally. We have our playground and we really want your feedback. Like getting feedback from our users and community helps drive innovation and what we're building. So with that, we encourage you to reach out to us on all of our community channels. Hopefully you know where they all are, but it's on Slack and you can find it all on VictoriaMetrics.com under our community section. So with that, I want to thank everyone for attending. Thank you, Matthias and Roman, and look forward to the next session. Bye.
Thank you. Bye.
Thanks. Bye.